Having learned the basic three structures of programming, or structured programming, we're going to present here the suggested programming steps in order to develop any program. We're going to start by looking at our SMATH Studio worksheet. There are 5 steps that are typically recommended to develop a program. First one, you need to identify the problem to be resolved. You need to know what you're trying to get out of the program. Second, identify the values that are going to be the input as well as the output of that solution. Third, develop an algorithm to solve the problem. An algorithm is basically a step-by-step or decisions or loops process that you're going to use to solve your problem. In the past, people will use flowcharts, which is a little bit too complicated, or pseudocode, which is easier. In pseudocode, to write your algorithm, and pseudocode is simply English-like sentences that describe the algorithm. Once you have an algorithm, then you translate it into computer code, and so it depends on what language you're using. In this case, we're going to be using the ideas of programming in SMATH Studio. And once you have something that works, then you test the program with a known data set. Okay, for example, develop a program to solve the quadratic equation. Identify the problem. We are given a quadratic equation and we need to solve for x. What will be the input? The input will be the coefficients of the quadratic equation a, b, and c. And the output, as we're going to look in detail here, could be a single root, 2 real roots, or 2 complex conjugate roots. For this, we need to know something about the problem. We all have solved second order or quadratic equations in the past. So what will be the solution algorithm? We're going to input ABC. In the case of SMATH Studio, basically, we provide those values as arguments to the function. Then we check if A is equal to 0, which could happen, that our equation has become a linear equation whose solution is unique and is equal to minus C over B. That's one option. If not, we're going to calculate the discriminant, and the discriminant is the quantity B squared minus 4AC. If that discriminant is positive, then we have 2 real roots calculated by these formulas. This is the quadratic equation solution that we know from high school. If the discriminant delta is equal to 0, then we have a single double root equal to b over 2a. If, on the other hand, delta is negative, then we have 2 complex conjugate roots whose real part is minus b over 2a, and imaginary part is minus square root of delta over 2a. And we're going to provide as output the type of solution that we found, whether it's linear, it's a linear equation, if it is 2 real equations, 1 double equation, 1 double solution real, or imaginary, like complex roots. And now we proceed to translate that to solution algorithm. Now, there's no unique way to program a program, and everybody has his own style and everybody has his own way of doing things. And when you get experience, you may skip some of the steps recommended here, but at this point I'm illustrating that case, in the case of using the 5 steps. And this is step number 4, where we have our function quad ABC, and then we have an if right there. If a is equal to 0, we have a linear equation where x is equal to minus c over 2. I have a variable called iSolve, which means I for an index, solve for the solution, and that will be equal to a linear equation for this case. If this is not true, if a is not 0, then we have to check the discriminant. We calculate the discriminant, and if that discriminant is greater than 0, then we have the case of 2 real roots whose values are given by x1 and x2, and I'm going to put that in the form of a vector. So the condition here is delta greater than 0. The truth part of the if statement is this one. The other option is the following. The next option, I need to check if delta is equal to 0. But in numerical calculations, you never check for delta exactly equal to 0 unless you're dealing with integer numbers. And so instead, we replace the condition delta equal to 0 by saying if the absolute value of delta is less than a very small quantity, 10 to the minus 5, for example, in this case, I'm going to call that the condition of delta equals 0. And for that, I'm going to proceed to say I'm going to have one single double root equal to minus b over 2a. If this is not true, that means the delta is negative, because I already checked the positive over here, in which case I have a real and imaginary part, whose the real part is this one, the imaginary part is this one, and I'm going to publish my result as a vector xr equal xi. So I have all the four options that I presented in here: linear equation, two real roots, one double root, real and imaginary part. Maybe I should even improve this and say double real root. And this is just a string of characters presented within double quotes. And so once I've gone through the whole process here, to this big if, I provide as a result a vector in which the first element is the type of solution found, and the second element is either one single value or a vector representing my solutions. So to check, that's the fifth step, check our program. I'm providing the case for the linear situation here and checking that indeed that will be the result. This case gives me two real roots, which are minus 1 and 3, and you can check this in the quadratic equation formula. Using this value, you obtain one double real root. That's when delta is close to 0. We check this value and we indeed obtain the same roots. And in this case, for quad 1, 2, 3, I get real and imaginary part of the solution. So it will be like plus and minus for the conjugate complex conjugate of those solutions. So this is a relatively simple problem, but I was able to follow the 5 steps recommended in here. And as I say, when you get experience, you're going to skip some of the steps, but come back to them just to check, make sure that you're developing your programs appropriately. And with that, we're going to finish this particular video.